So welcome everybody. Good afternoon. My name is Alex Razoumov. I am with Simon Fraser University, and I'm going to teach this English version of the introductory Python workshop. In today's workshop, we're going to use a remote system. You don't have to install Python on your own machine, but of course, if you have Python installed on your own machine, feel free to use it locally or to use the remote system that we'll be providing. Let me paste the details for the course, for the workshop. So the workshop notes, I will paste them into Slack right here. So we're using the Slack channel session 1 for Python. Please ask questions in the Slack channel, not in the Zoom chat, because we'll not be monitoring Zoom chat. So we'll be monitoring the Slack Python channel. And I just pasted the link to the Python workshop, but of course you can also find it through the main page. So if you go to the main page, click on the program either in English or in French, and then we're looking at Introduction to Programming in Python. So let's dive in without further ado. We'll talk about Python. So Python is an open source programming language that was initially developed back in the 1980s and early 1990s. And it was kind of not popular language for a while. And then it suddenly exploded in popularity. So it became really popular for scientific programming and for all kind of programming, probably in the mid 2000s. And it's been used a lot in scientific programming for the past 15 years. So there are many reasons for this. Python is really great when it comes to data processing. So a lot of you might be inclined to use, start up Excel, for example, when you need to punch in some numbers or do some data processing. And Excel is good on a small scale. So if you need to process, a few tens of lines of spreadsheets, Excel will probably do just fine. But for anything bigger, and by bigger, I mean, processing, thousands of lines or data points, millions of data points, billions of data points, Excel will easily break there. So, but Python can do it fairly easily. And so large data manipulation is much easier in Python than, let's say, in a spreadsheet. There are literally, hundreds and hundreds upon hundreds of libraries for, data processing, for machine learning, for visualization. And Python can handle large amounts of data. And limitation is really not comes from Python itself, but from your available computing resources. So let's say if you have a, laptop where you want to do data processing and you have, let's say, 16 gigabytes of memory, well, you can fit quite a lot of data into 16 gigabytes of memory. So Python will not be the limiting factor there, right? It's your, the resources, the memory, CPU and GPU processing power on your computer. But Python can also launch in parallel at scale on larger systems. So this is not what we're going to talk about today. Today is going to be just a basic introduction to Python. But the point here is that if you want to process very large data, Python is really a fantastic language for this. So it's more reproducible in the sense that you can take a script written in Python and then run it on a different machine or apply it to a different data set, and it can run on any platform. So, Windows, Mac, Linux, you can even run it on, Android or a phone or an iPhone as well. So Python is also a full-fledged programming language. And it's important to realize there is a big difference between traditional programming languages, compiled languages such as C or C++ and Fortran, and scripting languages like Python or R on the other hand. So Python is an interpreted language, which means that when you run a line of code in Python, it's being translated into machine language at runtime, right? So when you run any line of code in Python, it needs to be first translated into machine code, and that happens at runtime. So that means that Python is slower than compiled languages. So in compiled languages, once again, languages like Fortran, C, C++, typically you write a code, you compile the code, converting into machine code, and then you run the machine level code and it's really fast. So Python doesn't do it. It does conversion on the fly. And so that's one of the reasons why Python is very slow. So this is essentially probably the only major con of Python is that it's slow. And if you want to do any big processing, that takes days or weeks, for example, then Python probably is not the best language for this. But for quick processing, for data processing, for visualization, for machine learning, Python is really a fantastic language, especially that you'll probably be spending most of the time not in Python itself, but in one of the libraries, let's say for machine learning or for data processing. That most likely was written not in Python, but in a compiled language like C or C++. And so that library is going to be very fast. But anyway, this is just for a quick introduction. Because we have just over an hour for this workshop, I think we should just jump into Python itself. So there are many different ways of running Python. For example, if you have a machine on which you have a command line, for example, a Unix shell, you can just start Python inside the terminal and start typing commands there. So don't do this on your own machine. Here, I'm just showing you how I can do this. So here, I'm running a command line on my MacBook. And here I just start the Python interpreter, and then I can type, a Python command. Let's say print 1 divided by 2. I get the result, right? If I want to exit, I just press exit or Control D, and I'm back to the Unix shell. So also you can put a Python script inside a plain text file with a .py extension. And here I have an example of such a file. So here I have a file called print.py. It's just a text file. Right, but what this text file contains is a script in Python language. And if I run this file, it will simply execute this script, right? So it just prints the line print this from Python, right? So here the point is that you don't really need an integrated development if you integrated development environment. If you want to code in Python, you can run things right from the terminal. But today we're going to be using an integrated environment called Jupyter Notebooks. So this is a very, very popular way of running Python scripts. So the idea is that you start an environment inside your browser, and then you can execute Python code right inside the cells inside this notebook. So previously, when it was conceived about 5-6 years ago, maybe a little bit more than that, it was called IPython notebooks, and then later it was renamed Jupyter Notebooks. So today we'll be using Jupyter Notebooks, linked from the main page. If you're looking at the workshop page, so under Starting Python, there is a link to this notebook. So I'm going to open it in a new window. So there are two separate links. One is for English speakers, the other one is for French. So this is the English version of the workshop. So I'm just following the English link. And here it asks me to log in. So now I'm going to distribute the usernames and passwords. So let me paste the following into the Slack channel.
I can't join with from C because it joined with the email address.
Is there any question? Sorry. So here is.
So, and I continue working.
Can you unmute yourself if you don't have a question, please?
Doing Python for work reason. But I can just skip or and you join Python. We cannot join both of them.
It's like a...
Right. Thank you. All right, so into the Slack, I just pasted a link to usernames. And when I go to this page, you can select your username. So all usernames start with user and then two digits. So there are 6 characters in total. And please make sure you pick up an unused username. You want to make sure that nobody steps on each other's toes. So everybody is supposed to have a unique username. And write it down on a piece of paper. So this is the username, so user and then 2 digits. You'll be using to actually log into the cluster. And the password I'm going to paste into the Slack channel as well. And then you would type your username and password and then press sign in. So I'll be using an instructor's username, which is instructor, which is different from regular usernames. But the idea is the same. You paste your username and then your password. The password is the same for everybody. And then you press sign in. And when you do this, it will take a few seconds, but it will open this interface. So it's still starting out for me, where you have an option to select different things. So the thing that you want to select is under Notebook, you'll be selecting Python 3 Notebook. So in this dashboard, under Notebook, you're going to select Python 3 Notebook. And this is where we're going to be executing commands. Yeah.
Do you have a link to the Jupyter Hub? It wasn't in the document or in the Slack channel.
Yeah, absolutely. So it's right here. I'm going to paste it into the, so copy link into the Slack, but it's under starting. So I just pasted it into Slack, but it's also in the workshop notes under starting Python. So today we'll be using Jupyter Notebook. Here's a link to the English version right here, but I just pasted it into the Slack.
Thanks.
Sure. All right. So when you log in, you will see an interface similar to this one. So I'll just wait a minute to make sure that everybody can see this. If you don't, if you have trouble logging in, please let us know. Either type into Slack or unmute yourself. Okay, so is everybody okay? Everybody can see an interface similar to this one. So this is called a Jupyter Notebook. And here you would enter commands. So you see the cell where you can type in a command, right? So here I can, for example, type print, and then in brackets 1/2. And then to run this code, you have several options. You can click the run button right here at the top, which says run the selected cells in advance. So it will run the cell. Or I can go back to the cell. I will click on the cell again. And then in my case, I hit Shift Enter or Shift Return, depending on the label on your keyboard. So you can also do hit the cell, enter the cell that you want to run, and then Shift Return or Shift Enter. And that also runs it. Okay. So here I type the command and then I got the answer. So you see that 1 divided by 2 in Python is 0.5, and it's an answer with the decimal point. So you can see that this is Python 3, because in Python 2 the answer will actually be 0. Right. So Python 2 defaults to integers, whereas Python 3 actually does it properly in floating precision. Anyway, so let's talk a little bit about how we can interact with the cells in this notebook. So if you want to save your notebook for future, what you can do is you can go to File and then Save Notebook or Save Notebook As, and that will prompt to save the notebook, but it will save the notebook as a file on the remote system, which is probably not what you want to do. So because we're running on the remote system, what you probably want to do is you want to go to File, Download, and then when you choose it, it will download a notebook as a local file. And then by itself, this file will not be useful to you. But later on, when you work on a system where you can run Jupyter Notebooks, you can actually import it back, and then you can recreate your notebook this way. So the way you work with the cells is you can click on any cell, enter the code, and then hit Shift Return, and that will run this cell. So for example, here I can type 1 divided by 3, Shift Return, and that runs the cell. So here, if I want to run the first cell, I click on the cell and then hit Shift Return, and it runs the cell again. You can insert cells above or below the current cell. To do this, you would click on a cell, let's say in my case, the middle cell. And then if I want to insert a cell just above it, I click Escape and then character A, and that gives me a cell just above it. If I want to insert a cell just below it, I hit Escape followed by B. So let's say I want to insert a cell below this one. I hit Escape and then B, and that inserts a cell, just inserted this cell, right? If you want to delete a cell, you can click on a cell, for example, this one, hit Escape, and then hit X, yeah, and that deletes the cell. So for example, to delete this cell, I click on the cell, hit Escape, and then click X, and that deletes that cell. So let's start looking into Python itself. Python is a dynamically typed language. What this means is that all variables have types, but you don't declare these types explicitly. The types are inherited from the values. For example, here we have an integer variable. We'll say age is equal to 100. Right, so I'm going to say age is equal to 100, and then I run it. And then now age is an integer variable because I passed an integer value to it, and it's equal to 100. So in fact, I can print back this variable. I can type age, and then Shift Return will print it back. Or I can say print age, and then Shift Return, and it will also print. So the difference between cells with just the variable name and with a variable name encapsulated into the print statement is quite small, so don't worry about it for now. If you don't see printout in a longer piece of code and you want to make sure that something is printed, make sure that you include the print statement. But by default, the last thing in a cell is printed automatically anyway in Jupyter notebooks. Right? So here's an example of a string variable. So here we're going to say name is equal to JSON. And here name is a string variable, right? In fact, when I print it back, you see that it brings back JSON. And by the way, notice that here I use the double quotations. Here it printed back single quotations. So this difference is minor and it's actually not important. So in this case, you can use either single quotes or double quotes, just be consistent. So if you're opening with a single quote, then close with a single quote as well, and vice versa, right? But the point here is that here we used a string, assigned it to a variable, and it became a string variable. So we can actually check its type. We can say type, and then name. I can't remember. I use many different languages. So okay, yeah, it's just type in Python. So I say type name, and it prints back string, right? So name is a string variable because we assign a string value to it. Well, what about age? Type of age, and let's print back type. It's integer, so it's an integer variable. Now, if you want to print back the age and name in a single statement, you can run a command similar to this one. So we're running a print statement, a print function. So we're going to talk about functions in more detail soon. But here's a print function to which I pass the name and then a bunch of other things. And these things are separated by a comma. So name is age, years old. So here I'm passing a string variable. Here I'm passing another string. Here's an integer variable, and here's another string. And when I hit shift return, it just runs it and it prints back Jason is 100 years old. And notice that here I have separators, right? So between Jason and is, I have a separator. Between is and 100, I have a separator, and so on. But these separators are actually not inside these brackets, so I don't have to include them here because print function is smart enough. It automatically knows that if there is if it prints two things, then it by default will insert a single character space separator between them. You can assign multiple things to variables at the same time. You can do it in many different ways. So for example, here I assign value 1 integer to A and then value 2 to B, right? So here I'm actually running two commands. What I just typed is exactly the same as typing these two commands in two separate lines, right? So here I have two commands in a cell. Here I have one command in a cell, but commands can be merged together. Well, they can be put in a single line. You just need to use the proper separator. So when you want to put multiple commands in a single line in Python, use the semicolon separator. So here I'm assigning 1 to A and then 2 to B. You can also do it in this fashion. Use the so-called tuple notation. You can say A and B is equal to 1 and 2. And the end result is exactly the same. So A gets assigned 1, and then B gets assigned 2, right? So here, basically a couple of variables, and then to this couple of variables, we assign a couple of values. 1 goes to the first variable, 2 goes to the second variable. So if I print B, for example, you see that B is equal to 2. So what about this notation? I'm going to say A is equal to B is equal to 10. Anybody can guess what's going on here? Feel free to unmute or to type into Slack. So no guesses? All right. So what's going on here? We're actually changes the line to 17. No, not sure what you mean. No, so I'm looking right now at line number 19, and it's different from line 17. So what's happening here in line 19 is I'm assigning value 10, integer value, to both variables. So if I print back A and B, now both of them are equal to 10. So I'm assigning 10 to both A and to B. So this is what happens when you see this double assignment in a single statement. Variables can also change type, right? So for example, I can say B and Now I'm a string. So B was an integer variable previously, and now it's become a string variable, right? So if I inquire about the type of B, now it is a string variable. So variables are dynamic and they can change type on the fly, right? Which is very convenient. So here's a question. What will happen when you run the following piece of code? So let me just paste it into the notebook. I set initial to 1. So the value of the variable initial is equal to 1. Then I take that value, so initial is equal to 1, and I set it to position. And then I reassign, so after this line, the value of position is going to be equal to 1. And then I reassign a different value to initial. So now initial is equal to 2. So when I print position, anybody can tell me what will happen, whether I'll get 1 or 2. Feel free to unmute or to type into Slack. 1, yeah, great. Is there anybody else?
Yeah,
2?
1.
1, okay. So the vote is for 1. Well, let's try. It's 1, right? So it is 1, and the reason for this is because when you create a new variable, so in this case, position is a new variable, by assigning a value to it, you really are creating a new variable with its own value and its own memory address, right? So when after this line, there are 2 separate variables, initial and position. So it's not that position is pointing to initial. No, position is a totally separate variable with its own value. And then when you change the value of initial, it doesn't matter what the value of initial is because position has its own value, which is set to 1, right? So this applies to so-called elementary variables or unmutable variables. But when you try to do the same in Python with more complex objects, like, for example, with lists or dictionaries that we'll study later on, you will see that the same rule does not apply to more complex objects. So this rule applies only to elementary variables, just to a single variable. But when you talk about collections, when you create a new variable, like in this case, we have a list. We're going to talk about lists very soon. And then you assign the value of this list to a new list. A new list is actually going to be a pointer, right? So this is a difference between elementary or single variables in Python and collections. But we're not there yet, so we're not talking about collections yet. So let's try to assign a value helium. It's going to be a string to a variable called element, right? So now element is a string variable, and its value is helium. So in fact, if I print it, you'll see that its value is helium. And by the way, notice that the way I type in, you cannot really see my keyboard, by the way I type this, I don't type the full name of a variable. So here I assign helium to element. Now element variable is defined. And then when I want to print its name, type its name, I just say element, and then I hit tab, and it expands because element is the only continuation from the first 3 characters that I currently have in memory, defined in memory. And it's very convenient when you want to type very long command names, very long variable names. They will be just expanded automatically. All you need to do is start typing and then hit tab, and it will expand into a full name. So let's try to extract a single character. So let me type, let's actually see if this works. I'm not 100% sure it will work, but let's try. Let's count the number of characters inside the string variable element. So there are 6 characters. So length is a built-in function. Length of element gives you the number of characters in the string. There are 6 characters. Let's extract the first character. So I'm going to say element of 0, hit shift return, and you see that it extracted the first character. And here you immediately notice how in Python, counting starts from 0, right? So when you do any subsetting, when you do any indexing in Python, with a few exceptions, usually in Python, indexing starts with 0, right? So 0 gives you the first character. If you want to get the second character, you will say helium of 1, right? That will give you the second, helium, not helium, element. The variable's name is element. Element of 1 will give you the second variable and so on, right? So the last variable is going to be, there are 6 variables, 6 characters in total. So the last character is going to be element of 5, and that will give you the very last character. There's also another way, very handy way of, oh, there's a question. Somebody unmuted. Please, if you don't have a question, please mute yourself because we get some static noise, a little bit of echo. Please mute yourself, unless you have a question. So thank you. So it's very easy to get the last element using a slightly different notation. So here, if I type element of -1, it also gives you the last element. And the idea is that, so 1 is the second element, 0 is the first element, and then you keep going to the left, right? Subtracting 1. So 1, 0, -1 will give you just wrap around. So you wrap around from 0 to the last element. -1 will give you the last element. -2 will give you the second to last element, u, and so on. So in fact, if I type element of -2, it'll give me the second to last element, and so on, right? So this is very handy if you want to extract, the last element or second to last, and so on. You can also pass a range. Let's say in this case, I say element 0 to 3. This will give me a part of the string, so a substring, starting from character 3. Starting from character 0. Starting from character 0, it will give me 3 characters, right? So the way you read it, you can either read it starting from character number 0, give me 3 characters, or starting from character 0, go all the way up to character number 3, but do not include character number 3. So it's an open interval at the end. Do not include the third character. Only gives me characters 0, 1, and 2, right? And here's the result. So if you want to type element, let's say from 0 until character number 5, let's see what it gives us. It doesn't give us the last character, right? Because there are 6 characters. So to include the 6th character, I can type something like this. So from 0 to 6, but do not include 6. So give me 6 characters, index 0, 1, 2, 3, 4, and 5, right? You can also include a step. Let's say I want to list every second character starting from character number 0. So the syntax for that is to include yet another column. So with a step of 2, give me every second character. Right? If you want to have every second character starting from the second character starting from E, right? That's the way you would do it. So starting from the second character, which has index 1, go until the character number 6. Do not include character number 6. With a step of 2, give me a substring. So here's what I get. All right, let's try to extract a second digit of the following variable. So pay close attention to the variable type. So here I'm saying A is equal to 123. And how do you extract a second second digit from this variable? So can you do this? Let's try to do this. So second character is going to be index number 1, right? So I'm trying subsetting. And here I get an error message. So here it says integer object is not subscriptable. What does it mean? Well, previously we were working with string variables, right? So a string variable has a number of characters and you could subset it. So you can index certain characters by their numbers. But this is an integer number, right? It's not a string variable. So here, if we want to extract the character number 2, we actually have to convert this into a string, right? So I'm going to say string of A. I'm converting this into a string. And then from this string, I'm extracting the second character that will have index number 1, right? So in this case, I was able to extract the second digit from the number 123, right? Because I had to make it subscriptable, I had to convert it first to a string variable. So note that Python is case sensitive, right? So for example, we already have the variable E defined, lowercase e. If I try to print capital case E, well, it's not defined because in Python, case, uppercase, or lowercase matters, right? So you have to be consistent. I already showed you how you can convert from an integer variable to a string variable. Let's try to add 2 variables together. So we have a variable called name. I think I set it to JSON earlier. And then I'm going to add another string to it, right? So here I have the variable, a string variable, JSON. And then I'm going to add a string Smith to it. So here I'm just taking 2 variables and 2 string variables and adding them together. And that works. So when you add 2 strings together in Python, it will simply concatenate them. So it also included the space here, space character, because I put the space character here explicitly. So if I didn't have the space character, then I would not have a break between Jason and Smith, obviously. But the point here is if you have two strings, it's very easy to add them up, and what you get is a concatenation. So how about this? Let's say name, which is Jason, and let's multiply by an integer, let's say 5. What will happen? Well, let's try it. So when we multiply a string by an integer in Python, it will simply repeat that the string this number of times, right? So here in this case, we're repeating Jason 5 number of times, and the result is a string that simply the original string repeated 5 times. Now let's try to take an integer and add a character to it. A single character string. So here we have 1, and then we add to it, excuse me, a string containing single character A. So when I try to do this, we'll get an error message, and it says unsupported operand type for plus. So that means that you cannot take an integer and a string and add them together, right? So that mathematical operation does not make any sense. So what you can do is you can convert, if you want to concatenate two strings, you can convert the first one to a string, right? So now I have two strings and you can concatenate them. Or if you were to add, let's say 1 and 2, but 2 was a string and you want to convert it to a number, well, you can take the string containing digit 2 and convert it to an integer. And in this case, we have 1 plus integer 2. This is an integer number, and we get 3, right? So it makes sense. Are there any questions at this point? So I wasn't paying close attention to the chat in Slack. I'm not sure if there were any unanswered questions. I don't think so. Okay, well, let's continue. So let's talk very briefly about built-in libraries. Python comes with a number of built-in functions, and they form what is called the standard library. And so this standard library contains many modules, many functions. You already saw some of these functions. One of them is a print function, right? So if you put anything into a print function, it will simply print back its value. For example, A is equal to 123. Let's see if I have a string, hello, then printing a string will simply print back the string, and so on. There are also lots of different different functions like max, min, and lots of others. So for example, if I take max of 1, 2, 3, and 10, it will give me the maximum, the highest number of these, right? Because I'm applying the max function. So if I were to apply the min function to the same list of integers, it will always obviously give me the smallest number. So that's equal to 1. So how about this one? If I take uppercase A, lowercase a, and a digit 0. So what will happen? Let's try. And what happens is I get 0. And the reason for this is because the characters, these are simply ASCII characters, like text characters, that are ordered in order of their machine codes. And the order for ASCII characters is first go digits, then go uppercase letters, and then go lowercase letters, right? So if you apply the minimum function, it will simply look for something at the beginning of the sequence, and towards the beginning of the sequence. And then if you're applying the max function, it will look towards something at the end of the sequence, right? So when I'm comparing, let's say, A, lowercase a, and capital case A, then the minimum will give me the capital letter A, and so on. Right? And of course, in this example, you cannot compare these two because you're comparing an integer and a string, and these are just not comparable. So you can compare either two integers or two floating numbers or two strings, right? But not objects of different types. Another useful function is round, and what it will do, it will simply round a floating number to its nearest integer. So in this case, 3 is closer to 4 than to 3, right? And then it just rounds to 4. And you can also specify the number of digits that you want to round to. Let's say I want to have 2 significant digits after the decimal point. Well, you just pass the second argument to the round function, right? So the first argument is the number to round, and the second argument is the number of significant digits after the decimal point. So if you want to get help on any function, there are a couple of different ways you can approach this. One, the standard, so the usual traditional way in Python would be to type help function, and then let's say I want to get help on the round function. So I'll just help on round, I hit shift return, and it just gives me some information on what this round function does. So it can take up to 2 arguments, a number and number of significant digits, and this is what it does, right? So another way, and this is something that is unique to Jupyter Notebooks, is to type question mark and then help. Sorry, not help, round, right? So I'm getting help on the round function. So question mark and then the name of the function that you want to get help on, and then hit shift return. And that will give you something similar, just formatted differently, but just a quicker way of getting help on a function. So let's say I'm curious about the print function, right? So we already used print before, so let's get help on the print function. Here we get help on the print function. So it's something that, you know, prints values to a stream, and then you can actually print multiple things. And there are various modifiers, you know, end of line characters and so on, that we can optionally use, but we don't have to use this. Can I explain the element -2 again? And let's see, second last character. Yes, okay, great. Sorry, could not catch those. Please a little bit slower. Okay, we'll try to go a little bit slower. So here we're just looking at how we can get help on a function, right? And the easiest way to do this is to type the question mark and then the name of the function. Let's say one of the functions we use was min function, right? So let's get a help page on the min function. So question mark min, hit shift return or hit the run button, right? Just running a cell. And here you get the help page on the min function. Okay, so let's jump to conditionals. So like in any programming language, conditionals are very important because you can check for a statement, for a condition, and then execute either one command or another command, right? Execute one block or another block, depending on whether the statement is true or false. So let's consider the boundary between the antiquity and the Middle Ages. So let's say the boundary is at the year 476. So here we have the value of 830, so the year 830 assigned to the year, right? So here we have in a new cell, I'm typing year is equal to 830, and then I want to check whether this year belongs to you know, the antiquity times or falls into the Middle Ages, right? So here I have, I'm just going to copy and paste the following statement. So here I'm saying if year is greater than 476, and then I have this column. So this column is important in Python. So it means that if the condition evaluates to true, if this is true, then execute the following statement. And notice that the statement is printed here with indentation. So the way to do this indentation in Python, typically you would hit tab, but also optionally you can hit a certain number of spaces. For example, the traditional way to do this is 4 spaces. So 1, 2, 3, 4, right? So which one you do, it doesn't really matter. So both of them will work. So for example, I hit tab, I run the cell. And so what happens here is we have a condition, right? So let me just paste this condition into new cell. So this is a condition, right? And I can actually run this cell and it will return either true or false, right? So in this case, it evaluates to true. True, the value of this condition is true. So if this is true, then run this statement, right? And again, indentation here is very important because indentation means that whatever is indented is part of the if statement, right? For example, I can say print another line. So I'm going to say another line here, just a string variable. So now, because both of these guys are indented, both of them fall into the same if statement, right? So if it evaluates to true, and it will evaluate to true, then both of these will be printed, both of these lines, right? On the other hand, if you had something like this, let's say if I print another line here, and now it's not indented, now another line is not part of this if statement, right? So in this case, it's going to be printed anyway, because this line runs anyway. But let's just have something different. Let's have a smaller version of a year. Right? Let's say the year is 55 BC, and then so this evaluates now to false, right? So that means that this statement is not going to be printed, and this statement is not going to be printed as well, right? So if I run this, nothing is printed, right? Because both statements are inside the if loop. However, if I use a code like this where the year is set to 55. So the condition evaluates to false. And then this statement is not going to be printed because it's part of the if statement, right? Because it's intended. Whereas this one is not part of the if statement. So this one is going to be printed anyway, right? So this is what you see exactly. So you can include multiple commands, multiple lines of code into the if statement. Just make sure that every one of them is intended with either tab or for space characters. So indentation is really crucial in Python, unlike in other languages. Okay, so let's add another statement. Let's also add the else statement. So again, notice indentation, right? So here I have the if statement, and then if this evaluates to true, I want to run this line. So that means that this run has to be indented. And then the same here, if this line is not true, so else, then run this line. So this line also has to be indented, right? So here we have a single condition. If it's true, then print this line. If it's not true, then print this line, right? So what this will evaluate to? Well, this evaluates in this case the year is 205, so it evaluates to false. So that means that it will this year will fall into the classical antiquity period. So I hope that makes sense. You can also have the else if statement. And the idea, well, let's just type it from the beginning. So let's say x is equal to 5. And then I'm going to be checking if x is a positive number, negative number, or is 0, right? So I'm going to say if x is greater than 0, then I'm going to say print x is positive because it's greater than 0. Then else if, so let's check, elif. And I apologize, I program in many languages, so I constantly forget the exact syntax of commands. So else if, and notice that, again, I end this with the column, and then I'm going to say print x is negative. And actually, this is not, I need the conditions here. Here, I need to say else if x is smaller than 0, print x is negative. And then finally, I'm going to say else if both of these conditions are not met, then x is going to be 0. X is 0. All right. So in our case, x is, oops, I made a mistake somewhere. So let's see. And if, oh, I forgot the quote here. Okay, great. And of course, I forgot the quote here as well. So now x is equal to 5, so it is positive. So if I set it to, let's say, -2, that should evaluate to negative, right? Because this is true. So it prints back this line. And finally, if it's 0, now we get 0 is 0, which makes sense. Okay, any questions at this point on conditionals? So very important to remember the indentation, right? So if you want to type multiple commands inside the same else statement, or inside the inside the same if statement, or inside the same else if statement, or inside the same else statement, it's very important to use indentation. For example, here we still have x equal to 0, right? So this is still part of the last else statement. Great. All right. So if there are no questions, let's continue. So here is we have a code. I'll give you a few minutes to study this code. So try to guess what is wrong with this code. So here I said grade is equal to 85, so it's an integer variable, and then I want to convert from this numerical value to a string alphabetical grade, right? So I want to find out whether it's A, B, or C, right? So if grade is greater than 70, it's C. Greater than 80, it's B. Greater than 90, it's A, right? So if I print this back, it says grade is C, right? So what is the problem with this code? Take a few minutes. Feel free to unmute yourself or type into the chat. The question is, will you have access to Jupyter after the session ends? Yes, for some time. I don't know how long it's going to be valid, but I think for at least a few hours for sure. But I don't know when it will stop. But if you need to have access to this notebook, let us know. Just send us an email, and we can certainly make it available for next I don't know, next day or next few days.
I should mention that there's various ways to have notebooks online for free. If you have a Google account, you can have access to Google Colab, for example.
Yes. Yeah. Thank you, Paul. All right. So the code prints the answer to the first condition that is satisfied. Yes, exactly. So line 2 is true, so else does not apply. Right. So here we're simply looking at the first condition. It evaluates to true. 85 is greater than or equal to 70. By the way, this is greater than or equal to sign, right? Then it's evaluates to true. So this line is printed, and then we exit the else if statement. So the question is, how do we correct it, right? So what we need to do is we make this mutually exclusive, right? So one way to do this will be to revert the order. So to start not from the smallest, but from the highest. Or another way would be to revert the signs. So let's just change the order. So I'm going to paste this into a new cell, and then I'm going to correct it. So I'm going to change the order. If it's greater than 90, so we're descending down from the top, then it's A. And it's greater than 80, then it's B. If it's greater than 70, then it's going to be C. So now all these statements are mutually exclusive, right? So this one is not going to be evaluated unless this is false, right? And this way we can actually get to the right answer, right? So the point here is that when you write these complex else if statements, make sure that all your outcomes are mutually exclusive. Otherwise you will get into logical error. Right? Okay, so let's take a look at lists. So lists are collections, one of collection types in Python, and lists are really fantastic because you can use them for so many different purposes. So lists are essentially collections of values. So in this case, I have a list which is recorded list of temperature measurements, for example, right? So here I have a bunch of values, floating point values. They all have decimal points. And a list in Python always initiated with a square bracket. So opening and closing a square brackets always give you a list, right? Well, unless it's subsetting. So we saw example of a subsetting before, right? Remember when we did something like, let's say, hello, and oops. Let's say a string, oops, I'm not able to type. Oops. Okay, great. So here I have a string, and then let's say I want to extract the second character number 1. This is subsetting, right? So for subsetting, use square brackets, but on its own standalone, square brackets mean a list in Python. And lists are really great because you can put a collection of values into the same object, and then you can subset it and cycle through them, and so on. So lists can also be inhomogeneous. So in this case, it's a homogeneous list. All elements are floating values, right? But in fact, you can have a list which, I can say A is equal to, let's say, 1, 2, these are integers. Let's say 3.5, this is a floating variable. Let's say a string. Let's say a nested list, right? So I have a nested list which contains 10 and 20, right? So I need to close it properly. So here I have a list inside another list, right? And this just works fine in Python, right? So in here I have a very quite complex list. So the first two values are integers, then I have a floating variable, then a string, and then another list. So how do we subset lists in Python? Well, very easy, use square notation. So we took this list and we assign it to a variable called A. So to get the very first value of A, what do? Well, the very first value has index 0, right? So I'm going to say A of 0. So that gives me the very first value of the list, right? And that is equal to integer 1. Let's say I want to get hello. Well, hello is 0, 1, 2, 3, right? So A of 3 is going to be equal to hello. It's element number 4, right? Let's say I want to get 20. How would I do this? This 20. Well, this 20 is part of a nested list, right? So first I need to get this list, the nested list, and then I will get one of its elements, right? So if I'm going to say, let's get the very last element of A will give me my list 10 and 20, right? So A of -1 gives me 10 and 20, but I want to extract 20. So I'm going to take this list, and then out of this list, I'm going to extract the second element, right? So here we go. We take the last element in E, which is this list. And then out of this list, we extract the second element with the index 1, right? Or in fact, you could do this as, -1 and then -1. We're extracting, 20 is the last element in this nested list. And here, how we can get to 20 as well. If you want to get a range, well, use the same column notation before. Let's say you want to get a range, you want to get the first 3 values of A. Well, one way to do this will be A starting from 0 and going to 3, but not including 3, will give you the first 3 elements of this list. Let's say we want to extract the last 2 elements. So we want to extract hello and then the nested list. How do we do this? Well, multiple ways of doing this. So we're going to do, let's say, A from -2. Remember, this is -1, right? The last element is -1. This is -2. So we're starting with -2. We're starting with hello. And then we go all the way to the end. But in fact, you don't have to tell Python that you go all the way to the end. You can just leave it empty. And we will interpret it as the last 2 elements, right? So start from -2 and then go all the way to the end. In fact, when you do subsetting and you omit any of the numbers, Python will interpret them as the very end or the very beginning, depending on the context. So for example, here we have the first 3 characters, right? But that could also be accomplished in this way. So starting from the very beginning, which is empty. Empty means very beginning, going to character number 3, but not including character number 3. So that will give you the first 3 characters. Let's say if we do this, anybody can tell me without running this code what this will give me? So here we're not specifying the beginning, we're not specifying the end, right? We're just specifying the range without actually, telling Python what the range is. So yeah, it will give me the entire list exactly. So when we don't specify the end, it means the beginning. When you don't specify, the beginning, sorry. When you don't specify the beginning, it means from the very beginning. When you don't specify the end, it means go all the way to the end. So in this case, it gives us the entire list, exactly. All right, let's talk about how you can add things and delete things from a list. So let's define a list of prime numbers. So here we have 3 elements. So primes 2, 3, and 5. And then let's add another element to this list. So one way to do this would be, there are actually multiple ways of doing this, will be to use the append function. So in this case, the append function is a function of the primes object. So primes is a list and has a number of built-in functions. So to find out which functions you can access through this notation, you can start typing primes because it's already defined, and then dot, and then hit tab, and it will give you a list of functions. So one of them is append function. So I'm going to just click on it, and then I'm going to say 7. So it's a function, that's why you have round brackets. So we never pass something to a function like a print statement before. With print, we're using round brackets. So in this case, append is also a function. That's why we're using round brackets. So here we're appending something to primes. Nothing happened, right? But now if we type the value of primes, you see that we added a new element. So how do you remove elements? Well, there are multiple ways of doing this, depending on whether you want to remove an element by its value or by its index. So let's say we want to remove a character number 3, but I want to remove it as the second element. So character number 3 is the second element, right? So I can use the pop function. So I'm going to say primes, pop, remove element at the second location. So there's going to be element number 3. And when I run this function, it's, oh, actually, sorry, I forgot that indexing starts with 0. So actually it's element number 3, right? So it actually removed 5. So now if I type primes, it will give me this entire list without 5, because 5 indexing starts with 0. So 0, 1, 2. So now I have 0, 1, 2. I want to remove 3. How would I do this? Well, I just type primes pop element number 1, which is the second element, and that removed 3. So now I end up with 2 and 7. So pop removes an element by its index, by its positional number. But you can also remove an element by its value. Let's say you want to remove element number 7. And the function for this is remove. So I'm going to say primes remove, and then I remove the first occurrence of element number 7. I hit enter, and now primes contains just a single element, right? So depending on whether you remove by an index, by the positional number, or by the value, you will use different functions, pop and remove in these two cases. Okay, so let's start with an index, and let's add 3 variables to it. So here we start with an empty list, and this is perfectly fine in Python. So very convenient, by the way, if you're going to be adding things later on to it. So A is an empty list, and then we add 3 city names to it. So the result is that
sorry, remove is for all types or just integers?
No, for all types, yes, for all types. So actually, let's see this. So here we have A, and let's remove, let's say, I don't know, Kelowna, right? So let's remove Kelowna, and what this will do, it remove the very first occurrence of Kelowna. So if you had multiple Kelownas in this list, then it'll remove just the first one. But here I do remove Kelowna, and now I have just Vancouver and Toronto. So it's not just for integers. It can take any value. It could be a floating number, could be a string, could be something else.
Okay.
But it removes by value. So, and then we can use the usual rules of subsetting. So for example, at the very last element, we get A of -1 will give me Toronto because it's the last element, and so on. So we already talked about nested lists. Let's skip this. So you can search in a list using the following notation. So this is really, really convenient. Let's define a list of planet names. So Mercury, Venus, and Earth. So here is our list of 3 elements. Each element is a string. And then you can say Venus in B, right? So here I'm typing Venus, and I mistyped Venus intentionally. So lowercase Venus in B, let's say what it returns us is false because it's case sensitive, right? So what we need to do is type properly uppercase. And now this is actually a conditional statement, right? It's a condition that evaluates to true because Venus is one of the members of this list. And you can also say not in. So let's say, let's check the following statement. Let's say Jupyter, and Jupyter with a Y, like the planet, not the Jupyter notebook. So Jupyter not in B. So what we're checking here is whether, so I'm saying that Jupyter is not part of this list, right? And this should evaluate to true because Jupyter is really not part of this list. So it is true, right? Whereas if I say, let's say Venus not in B, that should evaluate to false because Venus is actually part of this list. So to sort a list, there are a number of ways of doing this, but there, one of the ways is a built-in sort function, really convenient. So here we have our list, and we can say B sort, and then it doesn't return anything because it sorted it in place. So now if I print B, you see that now it's actually sorted not in order of increasing distance from the sun, but alphabetically, right? So this is an alphabetical sorted list. All right, so here is a question, write a script to find the second largest number in the list. Let me just do it quickly here on the screen. Because we have only 20 minutes left, I won't give you any exercises. It's just, we just don't have time for this, but let's have a list which is set to, this list of numbers. And then we want to extract the second largest number in this list. So how do we do this? Well, we need to sort it, right? So I'm going to say A sort. So that will sort the list in place, right? That means that if I print it back, so it should be sorted now. But what I'm going to do is I want to extract the second largest number, right? Because it's sorted in increasing order. The second largest number is going to be towards the end, right? It's going to be -2. So this is the second largest number. So another way to do this would be to sort it in reverse order, and then pick up the second element in this list. So I'm going to say A sort, and then I'm going to bring up, because I don't remember syntax, the help page for the sort function, right? So question mark A.sort, this is the function I'm going to use. I'm going to bring the manual page, and the key I'm looking for is reverse true, right? So I'm going to set it to set it to true, so reverse true. So that means it's going to sort it in reverse order. And now it's in decreasing order, right? So now to extract the, oops, actually, I need to actually run the function, not get the help on it. So now it's actually in decreasing order. And then to get the second largest number, I need to start from the beginning. So it's actually, second is index 1, right? So this is the second largest number. So as with any problem in Python, there are usually different ways of doing things. So two different solutions to the same problem. There's a good question: can we apply math operations to lists? So not really. So you can do it through through loops. So we're going to talk about loops next. So you can loop through all elements of a list, and then you can apply a math operation on each element. But you cannot, in general, you cannot do this to a list, right? So if you have a large collection of numbers and you want to apply a math operation to these numbers, what you want to do is you want to initialize it as a NumPy array. So unfortunately, because this is a very short workshop, we're not covering NumPy arrays, but I'm going to show you where you can find more information about NumPy arrays. So loops are very useful in any programming languages because they let you cycle through, through collections. And so here we have a list, let's say 2, 3, and 5, right? And then I just cycle through all elements in this list. So what this code does is I have a loop variable called number. And this number simply takes values of 2, 3, and 5. So there are 5 loop iterations. And at each loop iteration, I simply print the value of number, right? So the result is I'm going to go through all the values and print each value. So to answer your question, can I apply math operations to lists? So let's see, there was, another question asked about NumPy. Yeah, so NumPy is the proper way of doing this, but if you wanted to do something like this here, for example, using lists, you could still do this, but you would need to cycle through all elements. And notice that here I also have indentation, so it's also very important. It's the same as with if else statements. Indentation means that whatever is here to indent it to the right, it's part of the for statement, right? So and I can have multiple commands inside the for loop. So here, what I can do is, let's say I want to multiply this number by 10, right? So I'm going to say print number by 10, right? So in this case, I'm applying a math operation, and then but I have to do it separately to each element of the list. So here we're looping through all elements in a collection called hello. So a string is a collection of characters, right? So that means that when I run this, it will simply print back all characters in the string hello, right? 1 character per line. So now here's something that you haven't seen before. Range is an interesting function because it will give us a range of integers from one number to another number, but not including the last number. So it's very peculiar syntax, but this is what Python has throughout, all constructs. So what we're doing here is we're going from 0, and then all integer numbers up to 3, but not including 3. So this does not include 3. And then we're printing each number. So in this case, we're printing 0, 1, and 2. So here is an example of how you can sum up numbers from 1 to 10. So we initialize a total, right? Total is set to 0. And then you go through all numbers from 1 to 10, right? And notice that if I say range of 10, this will actually not give me all numbers from 1 to 10. It will give me all numbers from from 0 to 9. So if I have just a single number in range, it will start from 0. So if I run it like this, you see that it starts from 0 and then runs to 9. So if I want to sum all numbers from 0 to 10, I can do either this. So I can say start from 1 and go to 11. So that will not include 11. It will end with 10. And then I'm going to say total is equal to total plus I. And then I'm going to print total. And notice that the previous line, so this line isn't intended, so it's part of the loop. This one runs after the loop finishes, right? So I'm printing the total after the loop finishes. And here we get the answer. So the total is equal to 55. Oops. Total is equal to 55. So I can also simplify this. I can say, instead of using this notation, I can say total plus equal to I. And this simply means increment, like in all other programming languages, pretty much. Increment the value of total by I, and that will achieve the same result. But it's actually a much simpler way of doing this, much more Pythonic way of doing this. So instead of organizing a for loop, what I can do is I can use what is called a list comprehension. And we'll skip through some sections because I'm kind of running out of time. We have only 10 minutes left. So list comprehension is really a fantastic way to create new lists out of existing lists or out of existing collections. So for example, let's say I want to create a list of integers from 1 to 10. I'm going to create a new list. So a list always initialized with square brackets. I'm going to say I for I in a range from 1 to 11, right? But not including 11. And then I run this. So what this will give me, it's a list of integers from 1 to 11, but not including 11, right? So this entire construct is a list, right? So I'm creating a list containing i's, but what is I? What is this I? I is taken from this for loop. It comes from the for loop for I in range. So here we have a collection that we are transforming into a new list. And this is great because you can actually use it to form a more complex list. So let's say I want to have a list of squares of all integers from 1 to 10. Well, the way I do this is just this, right? So this notation, asterisk, asterisk 2 means I to the power of 2. So I squared, where I is runs through all integers from 1 to 10 inclusive, right? And then, so here's the problem. How do you sum up all integers from 1 to 10? Well, very easy. You just do something like this, right? And then you take this list and you put this into a sum function, and then you get the result. So it's exactly the same result as here. So here you notice that here we're simply creating a list of all integers from 1 to 10, and then we are summing it up, right? So really, really easy notation. And it's really fantastic because you can achieve, something that you would normally do in a few lines of code, with just a very, very short statement. And this is called list comprehension. So you can also put if statements in list comprehension. So for example, here we have a list of all days of the week, right? Which is called week, Monday to Sunday. And then we have the weekend, right? And then the task is to create a list of days that are weekdays only. So Monday through Friday. So using list comprehension. Well, let's do this. So I'm going to say a list of days for D in a week. So let's cycle through all days of the week, but only include it if D is not in weekend. So I'm going to say, continue typing, if D not in weekend. Hit enter, and I get a list of all work days, right? So here I'm simply cycling through all days in the week, Monday to Sunday. So D for D in week, but only included if D is not part of the weekend. So this is really useful because you can form new lists based on some conditions. And so here I have let's say this statement. So here I have a list of colors. And let's say I want to form a new list of colors that are only 4 characters or shorter, right? So how do I do this? Here's my list of colors. Let's say C is a list of colors, right? And then I'm going to say, I don't know, let's call them short colors. So colors that contain only 4 characters or less. So I'm going to say, let's say X in C if length of X is 4 characters or less, right? So here include all colors from the original list C, but only if the number of characters in that list is 4 characters or less. Oops. And what do I do here? If length of X, length of C, sorry. No, length of X. What did I do wrong? Smaller than 4. Not seeing the error. Anybody can tell me what's wrong here? So invalid syntax X in, sorry, yeah, invalid syntax X for X in C. That's fine, because I didn't type the full command. So X for X in C, yeah, that's right syntax. If length of X is 4 characters or less. And then if I print short colors, here we get only 2 colors. All right. Okay, are there any questions that I have not that were not answered in the chat? I see there's some discussion of NumPy. Great. Right. Okay. Let's continue. So dictionaries are similar to lists in the sense that they're collections, but they're quite different. So lists are ordered sets of objects that you can access via their index, via their position, right? For example, if I have a list of colors, let's say to extract green from this list, this is element number 2. So we say, C of 1. And then that lets us extract green, right? So they are ordered collections of items, of values. Dictionaries, on the other hand, are unordered collections of key value pairs. So what does it mean? Well, let me give you an example. So here we have a dictionary of 3 pairs. So here we have a person's name and their favorite color. So Mary has orange as her favorite color. For John, it's green, and then for Eric, it's blue. So there are 3 pairs of names and colors, right? 3 pairs. And so the first item in each pair is the name. The second item is the value. So dictionaries, dictionary of favorites, so faves, is basically an unordered collection of key value pairs. So to access a value, you need to have to supply a key. So let's say a favorite value, a favorite color for Mary. I'm going to say Mary, and I use it as an index in square brackets. Is going to be orange. So for John, for example, is going to be green, and so on, right? So you access a value by a key. So this is a key. This is a value. Oops, this is a value. This is a key. This is a value. So if you cycle through a dictionary, so I'm going to cycle, I'm going to say for, let's say I in, and I'm going to cycle through the dictionary. Let's find out what it gives us, and we're going to print the value of I. It actually cycles through the keys, right? Not through the values, but through the keys only, through the names. So Mary, John, and Eric. If I want to print the values as well, I need to access them through subsetting. By saying favs of I, right? So I is the value, and then favs of I is going, sorry, I is the key, and favs of I is going to be the value, right? So key value pairs, right? So you can also extract things in using various functions from a dictionary. So for example, you can get a list of keys this way, right? So this gives you basically a collection of keys. If you want to extract all values, you can use this function. These will extract all values, and you can also extract all items by using the items function. So this will extract all pairs, right? So basically, it returns a collection of key value pairs. And why this is useful, this items function, is because, for example, you can do things like this. So, for example, you can use a tuple as a loop variable. So you can see use a pair key and a value as a loop variable. So this is a tuple, basically two numbers, right? Key and value. And then for, in favorites. And then let's print them back. So I'm going to say print K and V. And of course, here I need to use the items function, items, because here I'm cycling through both keys and values. And that lets me cycle through both keys and values. Okay. So there are a bunch of other topics that I really didn't have time to finish. So functions let you define a function. And this is useful because this way you can wrap some piece of code that you use all the time into a function, and then you can just call this function. And it's really, really, really convenient. So for example, let me start with a slightly more difficult example. Here we have a function that takes in the numerical year, numerical month, and numerical day. And what returns is the day of the week, alphabetical day of the week. So Monday, Tuesday, Wednesday, and so on. And so the way I define this function is here. So here I define a function. It has the name day of the week, and it takes 3 arguments. So def means I'm defining a function. And then again, indentation here is very important because what is indented is the body of the function. So there are 3 lines inside this function. And then to use this function, I simply say day of the week, the function name. And then let's paste in today. So it's 2023. We have February, and then today is the 14th. So it should be Tuesday, and it is Tuesday, right? So every time I run this function, so let's say 14th of February, 1999, which day of the week it was? Well, it was Sunday, and so on, right? So a function lets you define some piece of code that you can use repeatedly by using the function name and by passing, the arguments. And so unfortunately, I'm running out of time. And I think what I'll probably just walk you through the rest of this workshop. So you can pass multiple arguments to a function, and some of the arguments can be optional. So the idea is that if you don't pass an argument, but you have an optional argument defined, then this value that you can find in the, well, you'll see in the definition of the function will be used as the default value, right? So for example, if I have this function and I just pass a single value 10, so A is going to be equal to 10, and then B is equal to 1, and then coefficient is equal to 1. So both B and coefficient take the default values. And this is really useful because, you know, sometimes you just don't want to use all the you know, capabilities of functionality of a function. You just want to use something very simple. So let me show you a very simple example. Let's say print 1 and 2. We'll print 1 and 2. And by default, as I mentioned at the very beginning, they're separated by a space, right? So space is the default separator. But I can actually modify the separator. Let's say I want, instead of space, I want to use a dash. So the way I do this is I specify a different separator. So separator is a optional argument. So sep is an optional argument in the definition of the print function in Python. And when I do this, you see that now they're separated by a dash and so on. So very useful to have you know, optional arguments for additional functionality in functions. So we don't have time for this. So libraries, as I mentioned, there are literally hundreds and hundreds, probably thousands of really good, you know, data processing, visualization, etc. libraries in Python for pretty much any purpose. And so some libraries are included into what's called the standard library, but some of them are not part of the standard library, so you would need to install them separately. And one example of such function that came up in the conversation in the in the Slack chat was NumPy. So NumPy is a really, really important library, so not function library, for doing numerical calculations on arrays in Python. And it's really useful if you want to do linear algebra, if you want to have, you know, apply some function to a large collection of numbers, for example, large array of numbers, right? So NumPy is really important library. And then there are a bunch of other libraries that are built on top of NumPy. So Pandas, for example, is a library for working with two-dimensional tables and spreadsheets. Matplotlib and Plotly libraries are two plotting packages in Python, also built on top of NumPy. Scikit-image is a library for working with images in Python, also built on top of NumPy. Xarray is a library for working with labeled multidimensional arrays, also built on top of NumPy and Pandas. And just a quick shout out. So in here in the West, I'm based at Simon Fraser University, and here in Western Canada, we teach courses for researchers. And so if you follow the link here on this page from the workshop notes, there's actually a course that starts, it's a 2-week or 3-week, no, I think it's a 2-week course that starts next week, and it will be on more advanced libraries. So I'm going to cover NumPy, Pandas, you know, Xarray in much more detail starting next week. But this is not part of this humanities winter series. It's completely standalone workshop. But if you're interested, it's free for anybody to register and attend. So I think I will stop here. If there are any, we are out of time. If there are any questions that still need to be answered, I can stay a little bit longer in this room. Feel free to either type a question or ask by audio.